Hello, this is the class for Monday, March 30th. We're still in 10.1, and actually we're going to be in 10.1 for a while. There's a lot of stuff in here. I have one more example of a confidence interval before we move on to the other 10.1 stuff, which is hypothesis tests. So our last confidence interval example, I'm using numbers from the 2018 midterm elections. So there was a CNN exit poll done on the night of the election. And they asked lots of people lots of questions. But one of the things they asked people they talked to in Pennsylvania was who they voted for senator. So this is the Pennsylvania Senate vote, which was Bob Casey versus Lou Barletta. So when I used to watch election coverage on the TV, I often wondered how it was that when the polls closed, there was maybe 0% or 1% of precinct reporting, which I assume means that that's how much of the vote is counted, and they would call the election. You know, they would say, CNN is calling the election and Bob Casey has won Pennsylvania. You know, how could they possibly know that if they only have the results from 1% of the votes? And maybe all of those votes came from the same spot. You know, politics is very regional. And the way they do it is they base their guess on exit polls, not on the actual vote count. So they have people go to polls all across the state, all across the country, and ask people a bunch of questions, including who they voted for, and then a bunch of demographic questions also, like how old are you, what's your income, what's your religion, things like that. So they published these polls on their website. So when the people in Pennsylvania were asked Bob Casey versus Lou Barletta, out of 1,619 respondents, so those are people in Pennsylvania who gave answers to the poll, 909 voted for Casey, 678 voted for Barletta, and then there was 32 more who either voted for somebody else, or they chose not to answer that particular question. Okay, so let's find a 95% confidence interval for Bob Casey. So based on the data we have from these 1,619 people, that's our sample, we want to guess what percentage of voters voted for Bob Casey in all of Pennsylvania. And we're not just going to do a single guess, you know, we're going to give a range where we think there's a 95% chance that the actual proportion was. And after we answer that, we're also going to find the sample size to get a 95% confidence interval down to plus or minus 1%. Because when we find the confidence interval for the actual poll, you know, the range up and down from the ratio in our poll is going to be more than 1%. So if we wanted to get it down to 1%, we would have to poll more people. And the question is, how many people will we have to poll to get that range down to 1%? Okay, so over to Minitab and answer the first question. We'll put the second question in a different video. Okay, so we'll flip over to Minitab. These confidence intervals, remember they're under stat, basic statistics, and then one proportion, because we're estimating one proportion, which is the proportion that voted for Bob Casey. I don't have the raw data, I have the summary data, so we'll switch the drop menu to summarize data. And 909 out of 1619 voted for Bob Casey. Under options, double check that this is 95%. So I wanted 95% confidence interval that says, this says 95. This hypothesis thing, we're not using that yet. And remember, we are using the exact method and not the normal approximation. Okay, so let's see what we get. Hit OK. And this is our answer. There is a 95% chance that the real population proportion, the real proportion of all Pennsylvania voters who voted for Bob Casey is between 50, 0.536885 and 0.5858. Okay, so let me copy those into my Word document. 5369, 0.5369, and 0.5858. Okay, so you can see that even though we only talked to 1,619 people, and there's maybe a couple million voters in Pennsylvania, we have basically, we're pretty sure that Bob Casey won. There's a 95% chance that the proportion who voted for Casey is, like over 53 point something percent. He's got more than half the vote. And even if we change this to like a 99% confidence interval, because like there is a 5% chance that that's wrong. Well, first of all, if there's a 5% chance that's wrong, that leaves a 2.5% chance that he actually got more than 5858. But there's still a 2.5% chance he got less than 53. Now there's some space there, right? He can get less than 53 and still win. He only maybe loses if he gets under 50, and he has to be far enough under 50 to that Barletta is sort of like on the other side and passes him. So I'm going to change this to 99%, just so that now there's only a 1% chance that we're wrong, and hit OK. And so that flipped the number. Now it goes down to 52.9. He still wins, and now there's only a 1% chance we're wrong, and half of that 1% is that he won by even more. Okay, so you can see how CNN would be confident enough to say, we are calling the race for Bob Casey. Now, it is possible to actually figure out the percent, like sort of like the percent chance that he won the election, like to sort of expand this until you get all the way down to 50%. And that's kind of what the second type of analysis in this section, the hypothesis test, does. So that's a subject for a different day, though. Right now, we found a 99% confidence interval and a 95% confidence interval first, and all of the numbers in that range result in Bob Casey winning the election. So they're willing to call the election for Bob Casey. All right, so let me stop this video, and then we'll do the plus or minus 1% thing in a different video, because right now, the proportion in our sample is like 56% voted for him, but our range sort of went up to 58.5 and down to 53.5. So there's like a plus or minus like 2.5%. That's sort of like the range of how far off like our sample could be from the real answer, with a 95% likelihood. We want to get that down to 1%. So 56 just going up to 57 or down to 55. How much bigger does our sample need to be to make that happen? Okay, we'll stop this video.